Absolute value, that's a function, yes. I think it was absolute. Thank you. Extra credit on your test. We did absolute value functions, right? So these are kind of the two, like, once you have functions, these are the two side things that can happen. These are like two types of functions, inverse functions and absolute value. But what we did before this was the main meat of every function that ever exists. Like, not every function that ever exists has an inverse. Not every function that ever exists has an absolute value involved. But every function that ever exists has a, I guess function was section 1, right? And what was section 2? It was, right? It was domain and range. That's main. That is every function that ever exists has an input and has an output, right? And then what did we do third after we did domain and range? Or I got into this one. You can look at it. That's probably good. Better than not. I think it started with average rate of change, which every function that has more than 1 point. So now we're really just limiting a tiny bit. If it has 2 points, it's got one of these. So that's most functions in the world. That's every function that's not just a number. Heck, even y equals 2 has 2 points. 0, 2, 1, 2, 3, 2, 4, 2, right? And the average rate of change of that would be 0. So I'm telling you, this is every function that's not just 1 turns into 2, done. That would be. And then there was something that went along with that. I think we just did graphs, right? Yep. And then if you have a graph, what can you do to that graph? Right? We can transform, and there was something else I can't remember. Compose, which I talked about this the first hour, and this is why I'm doing this whole recap, is because I thought this was a really good, cool point. Someone else brought it up, not even I. They said these two things, you know what they actually kind of are? Transform and compose functions, those are two different sections we did, right? But you know what is kind of true about them? See if someone can. Here's a leading question. What kinda? What's the easiest transformation in the world to f of x? Easiest transformation in the world, the first one you always learn in high school and college algebra and this class, because we do it a bunch of times. Easiest one in the world is? What? Yeah, which one? What's the easiest vertical transform? I think so, right? That's like the basic stock one, right? Well, now, isn't that just f of x plus g of x? Where g of x is what? Is that an allowed thing? Is that a function in the world? G of x equals 1? Yeah. So technically, it's like that function, right? So there's just a cool point at some point. I was like, hey, we learned these two sections, but they're kind of pretty similar. That composition of functions is just transforming them using another function and not another number. I was like, yeah, you're right. That's a really good way to look at it. So there is a recap. If you're like, hey, I missed a few days of school, that is a bird's eye view of everything. But yesterday or the day before, I got all videos uploaded and posted. So if you need to miss a day and you want to go back and check out one of those lessons, they're all up and ready to go, which is great. I'm pumped about that. All right, so today we get to inverses, and we're starting a little late, so we'll have to move kind of fast. I'm sorry about that. Keywords for the whole day, 1-to-1. That is I'm glad we talked about it day one. I like that they included it in the domain conversation. So I told you we were going to get back to it, right? When we saw the words 1-to-1, we talked about it a little bit. We talked about first name, last name in this class, and then we said we'll see it again. Today's the day we see it again. I'm going to skip everything else and just say inverse functions are 1-to-1. Okay. Inverse functions are 1-to-1. And for an inverse function, what did they do in the simplest words possible? Without using the name. But yeah, they did. That's what I had to give it to my last class. That is the definition. If you want one definition for the whole day, and I'm going to say it in 4 words, switch, what? X and Y. If you want to sum all of today up into 4 words, that's it. Switch X and Y. Now, there's some stuff that works out of that, but that is the day. If you can remember that, you're going to be all right. Now, the definition flows out of it, and there's a few things that happen, but long story short, that's it. This side note is just saying, hey, be careful. It's not that. It's not that, right? Why is that a temptation for so many people? Anybody got any clue as to why that might be a temptation? For this, right? That's true, right? That's a true statement. Sorry, in your way. This isn't that. A lot of when I've taught students from different countries. Anybody not America high school? No, everybody was. Some really? No, dang it. Did you write inverse? Have you ever seen it written this way? Some people do a backwards arrow there. No, I think it was Netherlands or something last year that someone said that they write inverse functions like that instead of the -1. Which was like, what? -1 is normal? Yeah, most places. But I've seen that, and he was like, "Can I just do that?" And I was like, "Sure." It helps. That would help alleviate this fear that I don't think that I want everybody to see. It's not that. Don't do that. Don't be tempted to do that. That would be f of x with some good old parentheses all the way around it. That would be that, right? That's 1 over f of x. But the inverse is a different thing. All right. They give you the inverse. So what's the fact we know? I'm skipping down to example 1, just going straight into the meat of this. There's a fact that, okay, boom, I'm not even reading the question. You just see that, you know one fact. What's the fact? 6? Well, for which one? Now you got to tell me. Now you got to tell me which function you're talking about. This is x in the regular one?
Probably not.
Yeah, I know. Well, yeah. What did we just say the lesson of the day was? Switch x and y. So now what happens? H of 2 equals, would you say that those were switched as x and y? I would too. H of 2 equals 6. So what's your input output? Input was 2, and your output was 6. Cool. That's why I was saying, you're right, technically 6 is x for the inverse function. For the original function, 6 is 2, so now we have to be, for this lesson, we got to be careful which function we're talking about. H was the inverse, and it was asking what was the input for the original. All right. Now, how do we verify it? How do we make sure it has an inverse? How do we make sure, if it has an inverse, that is the inverse? I wish. Oh, do I wish. It's going to be a little bit harder than that. It's going to be what we've learned on one of those days from the beginning. We're going to take f of x, and we're going to put g of x inside of it, which is called a composite function. Thank you. And here is what I've, over office hours and a couple study sessions, here's, I think, the best way to view composite functions. The outside is f, right? The outside is f? So that's this function, this double underlined red function right there. Take the x and make it a, was anybody in this class when it did this? Somebody, 2 people in office hours, we've gone through it because we were struggling with this. We said, take the outside function, take the x, and it's no longer an x. What is it? No, it's not even a y. What is it? Okay, then it wasn't this class. It was first hour. We're going to make it a big old box. We took the x, and we're going to make it a big old box. And you know what we're going to do to that box? We're going to cube it, and we're going to subtract 4. And that's the outside. F is on outside of G, right? So you know why we were doing that? Because guess what goes right in the box? The blue function, right? The blue single underlined function is going straight into that box. And that was, I think, as I tried to make this simpler and we tried to work through it, that was the best way I could come up with. A consistent, simple way to look at composite functions that kind of takes it a step back from, there's 3 different x's when you do g of f of h of x. Make it a box on the outside, fill it in. If you had to do it again, you would make that x a box and fill it in with a different color. So does any mathematical stuff happen there? That looks cool. What? The 3's cancel? And you're left with x plus 4. Any other cool mathematical stuff happen? Oh, what? You're left with? That's nice. And I wish we were done, but we have to do it again. You know what we have to do the second time? Yep. G of f of x. Though I'm pretty sure it's going to be it. If it happens with one of them, it usually happens with the other. It's a really random case where it doesn't. X squared and the square root of x is one of those cases. There's a few different ones. Okay, so what goes on the outside this time? The big old blue function, but instead of the x, you know what I'm going to draw? Big old box. And you know what's going in that big old box? Not x minus 4. X cubed minus 4. And is there any math to work out there? Anything cool happen? The 4s? Okay, so you're left with cube root of x cubed. Anything else cool happen? And you're left with x. Look at that. X equals x. So f of g of x equals g of f of x. You know what that means they are? Inverses. Hooray. I'm going to zoom into that and give you about 2 minutes to try the next try it. Because last class, as we were working through these, we were like, oh, there's no new stuff to be learned or no weird stuff to happen. It is pretty much just a, hey, try it again, because this is kind of new and weird. This might be the first tougher thing we're doing. So I can give you like 2 minutes or half a song to try to if you have questions, ask the person next to you. Ask me. Should feel real darn similar if you're working through it. The first one worked? Nice. Okay, I got one person telling me the first one worked. I'll let someone try the second one. See, did the second one work? You already done with both of them? Sweet. Check mark. They're inverses. Cool. Not too bad. Before I even scroll down, I know you have your paper. Don't cheat. If the whole lesson of the day is summed up in 4 words, what are those 4 words? Sure. Switch x and y. So what do you think that means about domain and range? Boom. And the domain becomes the range. Oop, look. What used to be the domain is now the range. What used to be the range is now the domain. It just straight up swap. Which is great because look at this. It gives us a domain. So the domain of f, for f of x, the domain is this thing, and the range is this thing. So what do they change to? What we're going to do is let me get a color. Good color. I don't like that one. There we go. The range and the domain are going to, right? What?
No, I understand it,
But what? Why?
no, not why.
Questions are good to have. What's up? Oh, what function are you thinking of? No, I can help you come up with the question. I like thinking of hard things. Oh, like your homework? Like you started the homework early? And so now you have a question about domain and range? Well, hang on, don't count me on that. I haven't looked at every single problem. Domain turns into range. Oh, yeah. We're going to get to that right here. No, we're not. We're going to get to that right here. Try at 8. If you wait till try at 8, it's going to happen. But before we get to that, can we do some really easy ones first? And then if you pull your question up and you have a good one for when we get to try at 8, I promise your question's a good question. Ask it. No, keep it up so you have it. Okay, good. Because let's do this easy questions first because they are actually as easy as they look. What is f of 60? You just went like that, right? Cool. Like I said, we're going to slowly work our way to that how hard that question is because I think I know pretty similar questions to that one, and it's not easy. What about the inverse of 60? So you start here and go backwards, right? So what is the fact that goes along with that inverse so that our brains can see what's actually happening? There's an f of, or a function fact that goes along with that. Any thoughts? There's a blue function fact over there that I think is important to register. F of 70 is? Cool. This is kind of like we took a quiz. We took a quiz on Monday, and this is just a different way to ask a question we've already been asking all since the beginning. The question that was on the quiz was f of x equals like 4, I think. I don't remember for sure. Maybe it was -1 actually or something. And then the question was, what is x, right? This is just a different way of asking the same question, right? If f of x equals 60, what is x? What is that x value? Okay, let's keep going with some easy ones first. Invert 1, what's it turn into? We start on the y this time, right? And it looks like it turns into 3. What's the function fact that goes with that? Cool. And let's do another one. 4 turns into what? Looks kind of like 5.5, doesn't it? To me, I don't know. Well, no, where's it going to hit 4? It's not going to hit 4 at infinity. Because the blue line is probably going to keep going forever, right? And pass right through 4. At about x equals 5.5. Cool. Sweet. We're going to be able to make it to the hard question. I was worried because we started so late. All right, so what we said today is there are inverses. You set them, you compose them and see if you get x. You look at y and you go to x, basically, whether it's on a table, on a graph, with the function because you swapped them. But how do we actually find the inverse? What if it's a blank slate and they just say, hey, here's a function, find the inverse? There's no checking to be done. There's no whatever. Long story short, one of these, we're going to do all 4 steps. One of these 4 steps is the key step. Do you see the key step? That looks like the lesson of the day, right? If you forget all 4 of these steps and you're on your final exam because this is early in the year and your final's late and you get an inverse question and you get confused and you can't remember the 4 steps exactly, if you can remember that green step, I think you're going to be all right. I think you're going to be able to do it with just that green step. But let's work our way through one at a time to see them play out. So first things first, make sure it's 1-to-1. Is that function 1-to-1 and how could we possibly know? I think that goes back to functions you need to know. The first day when I gave you the paper and on the back of it I said, please go learn this. And perhaps next year I'll give you a quiz on that because this is coming to bite us in the butt a lot. What does that function look like? But what does the function look like? What is the easiest word, even easier than the word you just used? That's the easy word. Say it louder. It's a line. You can say linear. You can say it has a multiplicity of 1, which means it only crosses the x-axis once and it doesn't bounce at that spot. But just say the word line. Because you know what every line does? Well, except for one. Every line except for one passes what? Which means it's horizontal line test, check, which means it's 1-to-1. There's only one type of line that doesn't pass the horizontal line test. It's a horizontal line, but that's the name of the test. So, check, mark. It's 1-to-1. That was step 1, right? Step 1, check, because of the HLT. Step 2 said to do what? Oh, no. I don't like that. I'm going to switch those 2 orders. You can do it that way. I'm not. I'm going to go ahead and swap x and y. I don't like solving for x. I like solving for y by itself. We say that all the time, get y by itself. So I'm going to swap x and y. We're going to get x equals 1/3 y. Right? Step 3, solve for y. You're good math people. You can do that, right? This is the step where everybody screws up. Historically, everybody's pretty good at these, except for that step 3. That step 3 requires you to have gone to college algebra and not cheated on the ALEKS test, and therefore knowing things, which is good to know them, but it's hard. This is the mess up step. Anybody got a good first move? Good call. If you distributed, totally okay, you can do that. It's just going to yield you an extra step. What you do to one side, you do to the other side. So we're left with 3x equals y minus 5. Add that 5 over, right? And your final y is equal to 3x plus 5. And then the last but not least step that they ask us to do is, what color haven't I used yet? I don't know. I used all the colors. Orange. 4, they said, hey, don't leave it like that. Write it nice and pretty with the function notation. Oh. You mean the 1/3?
No, the actual 3 to the...
Because it canceled the 3 on the outside before distributing, so I was going to leave it alone. If you wanted, you could, but then you would also need to distribute that 1/3 to watch them cancel each other. You could distribute both. It would be 3y minus 15, right?
Yeah.
And then don't you also need to distribute that 1/3?
Yeah.
Which would, underline the 3y, make it back to y, which is great, and divide by 15. Right. If you want to see it prettier, look, if you want to see the canceling happen way prettier, we always do it on the outside just because that's the parallel looking argument. You can multiply by 3 on both sides, right? We could have multiplied by 3 right here. And now they cancel right next to each other instead of like far away from each other. 3 over 3 is 1. You multiply by 3 on both sides. Okay, we got 15 minutes for a break. Here we go. You want to ask your question? Can you ask your question? Because I think it's going to be the question that this question's asking, but I want to see if we can do it without just jumping into the problem or explore it. 15 minutes is plenty for this. I'm just curious as to what you were going to ask. It's about domain and range, right? And this problem asks us for domain and, oh, it doesn't ask us for range. Oh, well, we're going to do range anyways. That's hilarious. That's way easier than what I did earlier, but that's okay. What was it asking for? Go find the inverse. Go find the inverse while she looks for the question. You just learned how to do the inverse. Switch them and solve. You found it? Is it similar? No?
What's this one? I didn't understand. Oh, wait, it's not this one.
Why they stopped at randomly 8?
I know it's 8 because it's right here.
We gotta find it. All right. Anybody good with the inverses and already got it? Oh no. Step 1. So I'm gonna just actually not even this isn't even one of the steps, but I'm gonna write it as y, right? And then you know what I'm gonna do with x and y? Switch them. And you know what I'm gonna do with y? Wait, that's not what? What's going on there? Oh, lol. What you want to move first? So you're going to subtract 2. So you're left with x minus 2 equals negative root y. What about now? Can't you just multiply by negative 1? Same thing. I'm just being mean. Divide by negative 1. Divide by negative 1. So now we're left with root y equals what? What does that negative 1 do to the whole side? Just the x or both of them? Are you sure? Are you sure that that negative 1 switches both sides? Anybody else? Disagree? No, I don't disagree, but I just wanted to be very clear that everybody in the world, I think we saw this at one point earlier, what does everybody want to do immediately? Well, where the heck does the negative 1 go to both of them, but the a wouldn't? I just made that up real quick because of you saying so quickly it goes to both. You said so quickly, negative 1 goes to both, right? Because you distribute a negative 1. You were right. So why on earth what's the instinct here? It's okay, you're not alone. I made it up because I know it's the instinct because we do it all the time. What does everybody want to do? That? Then how did you know the negative 1 went to both, but you didn't think the a did? Not you. I'm just saying the royal you. That's a good thought to have, right? So whenever you get a problem like this and you get tempted to cancel it, stop, pause, think about that negative 1 that you know goes to both sides. And then give it to both sides and go a over a plus 1 over a. And that's okay. Right? Good side lesson on the one lesson. Only because you said it so quickly. You said negative 1 goes to both. And it's like, Okay, then why is this the most common mistake in up through Cal 3? So it's not just you, and it's not just this class, and it's not just college algebra. It is. Okay, let's keep going then. Sorry, that was a side note. We switched both sides, right? The negative that you said gets distributed, flip the signs for both of them. Awesome. We got one more thing to do. Square both sides. And because you're all masters of college algebra and really good at foiling, and if you're not, come to office hours immediately before this class or at 8 a.m. Every day at 8 or every day at 11, office hours. Those are the 2 times. I'm teaching all the other times. So you're so good at foiling that you're going to say x squared minus 4x plus 4, right? Is that the inverse? Sweet. We have 8 minutes to explore this problem. We're not doing the last one. We'll talk about it a little, but we won't do it in class today. We have 8 minutes to explore this really big hiccup that just occurred. Got a really big problem. Is that the right answer? Absolutely. What's the problem? What does that look like? Anybody got a vague idea, even if you don't know exactly where the points are, what that looks like? Kind of like that? Probably not exactly that because it's got to intercept at negative or at positive 4, but it's something like that. What's the problem? That's not 1-to-1, right? Okay, it's not 1-to-1. We got to figure something out. That's why the second half of this problem is here. State the domains of both. So in a little side note, I'm going to say let's start with the first one and go we're just for f of x right now, starting with f of x. What's the domain? I might not agree. For f of x, remember what the first thing you think when you think of the word domain? Restrictions. Bad numbers. What are the bad numbers? Where's the restriction here? Square root can't be a negative number, right? Which means the inside better be cool. Let's write that. That means that x better be bigger than or equal to 0. How do we write that in domain form? 0 to infinity. Cool. Pause. Didn't we learn something a second ago? If it's the domain of f of x, then it's the of the inverse. Oh, I won't write it first. I'll write it second. But we need to find the domain of the inverse. That's a little harder. How can we find the range of this red function? Or the range of the regular or the original function? This would be a tough, if this were posed to you on a quiz or a test, this would be one of the tougher problems I can think of for all of chapter 1, is what's the range of that function? What is the range of f of x? Like, how are we going to know the range? Yeah, we probably got to look at a lot of stuff. Not just vertical shifts, everything that goes with it. So here's the graph. Anybody know what the original graph kind of looks like? Parabola sideways? I mean, that's cool. It's the inverse. I mean, like that? So what are the shifts that happened? This is one of them, blue. That's the first one you do. You do the reflection first. Outside of the square root reflection, so it's a vertical reflection. And then what does this underline 2 do? Whoa. No, it's added. It's not multiplied. That would be if it were multiplied. A stretch would be a 2 right there. It's up. What color is it? Orange. It's up 1 up 2. So it is that. And I'll do it orange. So there's the orange function, right? And it went up 2. So what does it feel like the range is for the orange function? We go low to high, not high to low. Be careful. But you're right about the 2 numbers. He said 2 to the negative infinity because of reading left to right. We're not reading left to right because left to right is negative infinity this way and infinity that way, right? We do the same process, but we go from the lowest number to the highest number. So we go bottom to top. So the range there is going to be negative infinity, and where does it stop at? 2. Which means that's what? That range is now the domain of the inverse. 2, 2. Wait, no. What am I doing? Don't flip it around. It's exactly the same. Negative infinity to 2. And what did that just do to our parabola? I did draw it kind of okay. What did that do to our parabola? If this was kind of our parabola, I know I said it wasn't perfect, but if this is kind of our parabola, what did we just do to the domain? Where does it stop at? Where does the domain stop at? Could we call that 2 maybe? Okay, so it's not just like a cute little thing where it's like, oh, the domain kind of just, something else happens. What happens to the whole right side of that? It's not even considered anymore. That would be like if I were giving out test grades and I kicked out half of the class and I said, I'm only giving, it's not that they didn't even get a grade anymore. It's not that they got a grade and then got kicked out, right? It's that get out and now I'm going to grade the tests. They don't even get an X value to look at. They're not part of the domain. They're not part of the X's. Wait, did I mess up? No, negative infinity. Stop at 2. Oh, I just messed up when I drew it. It should be an arrow, right? Now it looks, that's what it should look like. Okay, with what? I know. Okay, well, slow down, breathe. We found the inverse using the inverse steps. You can do that. There's half the points. You're done. Rewind like 2 weeks of school. We found a domain, right? You can do that. You can find a domain. Range, little harder to find. And then we just used those 2 things and swapped them. And then drew a little picture to show what it kind of looks like. Here's a cool thought, though. We're not going to do the next problem, but I do want to look at this. That's kind of exactly what we just did. A square root function and half of a parabola. That's pretty cool. A square root function is probably the... I need a green. Where's the green? I guess that's more teal, but... That's probably like the square root of x, right? Looks like what somebody earlier said the square root looks like. And this is probably like x squared, right? But it's x squared with the domain restriction. It's x squared cut in half like we just did. And what do you notice about that? It says reflection across the line y equal x. That's a big way to say what we're about to look at. What point is this red point? Like, just the easiest math question in the world. What's that point? How many squares does it take me to get to the orange line? Oh, you can't see the squares as easy. I can't. Oh, man. You can't see the squares on the projector very good. Yeah, it's 1. Here's the square. I'll trace it. That's the square. That's the square. That's a square. That's a square. How many squares did it take to get over there? So if I was reflecting it, how many more squares? Did that hit the line? Perfect. Now, unrelated, what point is that? What was the short lesson of the whole day? Look at those 2 points. Right? What about this point right here? It's on the graph. What's that red point? 1, 1? What about the reflection across the line to get to the other color? It's already on there. Switch X and Y. Ah. What about 0, 0? Same thing? Cool. Very cool. You know what the next nice neat point probably would be? If you had to guess for a square root function? Well, for a square root function it'd be 9, 3, which means that's a way farther away, right? So if you were to deflect it, it would have to go way taller. And you know what the point it would end up reaching is? The switch of X and Y, which is 3, 9. Graphical representation of what we've already done all day long. Okay. Yeah? What's up?
Let's go back to the top one.
This whole problem right here? Yes.
And that little graph right there.
This one? Oh, just graphing the original function. It's probably pretty important for me to be really clear. Whoops. That is not a inverse. This is not a new topic. This is just us doing a refresher on how to graph f of x. And the reason it has 3 graphs on it is because it's a refresher from the transformation section where we blue reflect, yellow shift up.